Dear students, welcome to my YouTube channel. Now I am going to explain the concept of Cauchy and legendary differential equation. Before starting Cauchy and legendary differential equation, just recall the concept of differential equation with constant coefficients. We know that differential equation with constant coefficient can be written in the form f of d into y equals to phi of x. Here f of d is function of derivatives into y equals to phi of x. Here, to find the solution of this type of differential equation with constant coefficients, we have to find complementary function and particular integral. Their sum becomes the complete solution of given differential equation. Here, legendary linear differential equation. Legendary equation given in the form a naught into ax plus b whole square y double dash plus a1 into ax plus b into y dash plus a2y equals to phi of x. Here observe that y dash multiplied by the term ax plus b, y double dash multiplied by ax plus b whole square. This equation is called legendary linear differential equation. To find the solution of legendary differential equation, first we have to reduce this differential equation with a variable coefficient into, we have to reduce it into differential equation with constant coefficients. We have to reduce this legendary differential equation with a variable coefficient into differential equation with constant coefficients. By taking substitution, ax plus b equals to e power t, ax plus b equals to e power t, and ax plus b into y dash equals to a into dy. And here ax plus b whole square into y double dash equals to a square d into d minus 1 into y. Is it clear? We have to reduce this legendary equation into differential equation with constant coefficients by taking this substitution. After substituting these terms, we have to reduce it into the standard form. Then compute complementary function yc and particular integral yp. Then their sum becomes solution, but it in terms of t. So substitute back to t equals to log of ax plus b. We get solution in terms of x. Next, Cauchy linear differential equation. Cauchy equation given in the form a naught into x square y double dash plus a1 into xy dash plus a2 into y equals to phi of x. Here observe that y dash multiplied with x and y double dash multiplied with x square. This equation is called Cauchy linear differential equation. To find the solution of Cauchy linear equation with variable coefficient, observe that here the coefficient is a variable. So we have to reduce it into differential equation with constant coefficients. Here, to reduce it into constant coefficient, we have to take substitution x equal to e power t and xy dash, here xy dash equal to dy and x square y double dash equal to d into d minus 1 into y. Similarly, if suppose the given differential equation is third order derivative x cube y triple dash, we have to substitute this term. After substituting these terms, we have to reduce it into standard form, but function in the RHS we have function of t. Find out the complementary function and particular integral. Their sum becomes the solution, but in terms of t. Substitute back t equals to log x. So we get the solution in terms of x. Here, how to identify the given problem is a differential equation with constant coefficients or Cauchy or legendary equation. It's very simple by observing the coefficients. Look at here, this differential equation having the coefficients 6 and 17 and 12 here. These coefficients are constants. Therefore, this is differential equation with constant coefficients. The solution obtained by finding complementary function and particular integral. Next, Cauchy linear differential equation. Here In Cauchy equation, y dash multiplied by x and y double dash multiplied by x square. Here these are the examples. Here dy by dx has the coefficient x. Here d square y by dx square has x square. Similarly, this is another example. And in the legendary differential equation, y dash multiplied by ax plus b in this form. dy by dx multiplied by 1 plus x. d square y by dx square multiplied by 1 plus x whole square. Here in the another example, y dash multiplied by 2x plus 1, y double dash multiplied with 2x plus 1 whole square. So these are the differences. Let's see one problem on Cauchy linear differential equation. Here suppose the problem is solve x square d square y by dx square minus 3x dy by dx plus 4y equals to 1 plus x whole square. Here equation can be written as the second order derivative can be written as y double dash. Here dy by dx can be written as y dash. Similarly, this is a given equation. It is in the standard form a naught x square y double dash. Here observe that y double dash multiplied with x square and y dash multiplied with x. So it is in the standard form of Cauchy equation. Therefore, you have to conclude that it is Cauchy linear differential equation. Then we have to reduce this equation into differential equation with constant coefficient. So substitute x equal to e power t and xy dash equal to dy and x square y double dash equal to d into d minus 1 into y. Substitute into given equation. X square y double dash replaced by d minus 1 into y minus 3 and xy dash replaced by dy plus remaining coefficients as it is. And in the place of RHS we have, in RHS we have x, so replace it by e power t. Now simplify the LHS. So here y is common, take it outside. So it is in the form f of d into y equals to f of t function of t. So this is differential equation with constant coefficients here. 4 here minus 3, here is 1. Therefore this is differential equation with constant coefficient. Now we have to find complementary function and particular integral. Here to find complementary function, write down auxiliary equation, find the roots. Here roots are 2, 2 repeated. Therefore complementary function becomes like this. And particular integral f of d by RHS divided by f of d. And here numerator is 1 plus e power t whole square. Expand the term. We get 1 plus 2 e power t plus e power 2t. Split the terms into 3 terms. So denote it by, first term denoted by p1, second term p2, third term p3. Here evaluate one by one. P1 equals to 1 can be written as e power 0t divided by d square minus 4d plus 4. Here we know that this is type 1 particular integral. We have to substitute in type 1 particular integral. We have to replace d by a value is 0, therefore value is 1 by 4. In the second term p2 e power t, here a value is 1, replace d by 1 and value is 2 into e power t. Similarly in the third term, this is also type 1 particular integral, a value is 2, replace d by 2. So we get here denominator, after replacing d by 2, denominator equals to 0. Therefore we have to multiply it by 1t and differentiate the denominator. D square derivative with respect to d is 2d and minus 4d derivative is minus 4. Now substitute d equals to 2. Again it leads to 0. Therefore again multiply another term t. So t becomes t square and again differentiate the denominator. 2d derivative is 2. So here now there is no d in the denominator. So this is the particular integral. So p1 plus p2 plus p3 is the particular integral. Then complete solution obtained by yc plus yp. Here this is in terms of t. So substitute back t equals to log x. So we get complete solution of Cauchy differential equation.